Okay, let's look at section 2.3 that's talking about perfect square trinomials. First of all, one thing to keep in mind is this part that you see right here and this part, these are the factored versions. This right here with 3 or tri terms, that's the trinomial. So when you get a problem like down here in the first part of 2.3, that's in trinomial form. And what's the directions? That says factor these perfect square trinomials. So I'm just going to go straight into doing some. Let's do problem 1. Move my notebook. Okay, m squared minus 8m plus 16. The rule about recognizing a perfect square trinomial is if the middle term should be 2 times the root of this side times the root of this side. So is it 2 times 4 is 8 times m? Yeah, it is. So that one could have been a negative 4. And then that would have made that negative 8. But anyway, it's got to be 2 times the roots. So that's how you recognize a perfect square trinomial. We know this one's a perfect square trinomial because it's in that section, but if you were doing just a random problem, that's how you would recognize it. So we're told to factor these. So I'm just going to factor it and then check my work. So I'll write it out. This is how I would have you do these problems. Plus 16. Okay. I'm going to factor it. M minus 4 times m minus 4. Perfect squares are always the same term times the same term. That's why they can be condensed to just mean m minus 4 squared. And that would be your answer. But I'm going to check my work right below this. Okay, it's m times m is m squared minus 4m minus 4m plus 16. So is that right? That'd be a negative 8m? Yep. Just like the original. Alright, let's do problem 2. Problem 2 says 4y minus 4y squared plus y cubed. Alright, they're going to try to get you on problem 2. All it is they just didn't organize the variables in the right order. So all you have to do is go back and do that. We can, first off, I know that we can factor out a y no matter what order they're written in. So let's do that first. Y times 4 minus 4y plus, factor that out, y squared. So there you go. Alright, now let's get it in the right order. Y times y squared. Next in the middle would be our single powered y, and then at the very end, just the plain old number. Okay, so this is our perfect square inside here. Should be, the middle should be twice 2 times this root, 2y, times this root, 2, or negative 2. So anyway, let's do that real quick. Y times, I'm saying it's going to be y and a negative 2, so that will make the end right there. I know that. Anyway, okay, let's check our work. Y times y squared minus 2y plus 4. Would that come to the original? Y times 4 minus 4y plus, I'm sorry, would that come to the original? It would be y times y squared minus 4y, y squared minus 4y plus 4. Okay, the order was confusing me there. There we go. Y squared minus 4y plus 4. Yes, it comes to the original. So the best way to write that, I'm just going to come off of this one because this is the factored version. This down here is just checking my work. But the factored version is what they want. It'd be y times y minus 2. Since it's a perfect square and it does the same thing to itself, it's simpler just to say squared. That is your answer. Alright, let's do number 3. Okay, number 3 is a squared minus 16a plus 64. Okay, that is that's going to be factorable to a minus 8 times a minus 8. And let's check our work. A times a is a squared minus 8a minus 8a plus 64. It's so easy to check your work on these, it's best to always play it safe. Minus 16a plus 64. Yes, it comes to the same thing. So right here where we factored it, we need to write that out the simplest way, which would just be a minus 8 squared. Notice in the middle, by the way, in trinomial form, how perfect squares have this pattern where the middle is 2 times this root times this root, which in this case was a negative 8, not a positive. That way it did indeed come to negative 16a. Just want you to keep that in mind for the next section that we'll be doing. Let's do number 4. 3x squared. 3x squared plus 6xy plus 3y squared. Okay? First thing we can do is factor out just these numbers. I can see a 3 can be factored out of everything. That's the only thing that's common in each one. Okay, so 3 times x squared plus 2xy plus y squared. Okay, now in order to factor this one, we can see it's a trinomial pattern because it's 2 times the root of this one, x, times the root of this one, y. So anyway, just keep that pattern in mind. 3 times, by doing x plus y, that should do it. Like that. Check my work. 3 times x squared plus xy plus another xy plus y squared. And that is going to come to x squared plus 2xy plus y squared. So this way was the right way to factor it. Let's write it out the simple way. 3 times x plus y squared. Okay, let's do number 5. Number 5 is 9x squared minus 42x plus 49. Okay, let's make my 2 sets of parentheses to start out with. That'll be a 3x for this side. And I'm thinking this is going to be a negative 7. I know it's a perfect square. I know both of these have to be alike. So this one's got to be, the root of this one is just negative 7 or 7. But since this is a negative, that's how I know to put a negative. 3x is 9x squared. I'm just checking my work. Plus 49. Checking your work gets you really comfortable with working the FOIL method and all of that. Going 3x times 3x, 3x times negative 7, negative 7 times 3x, negative times negative. It gets you comfortable with doing that if you're not already. Okay, so the simpler way to write this, because it does indeed turn out to be what it was, would just be 3x minus 7, all of that squared, done twice. Okay, number 6. Last one, 36 n squared minus 12n plus 1. Okay, this isn't interesting, but this is in the right order despite, you know, what your first impression might be. As long as the variables line up, it's in the right order. So the n squared, the root of this one is just 6n, like that. The root of this far end is just 1. So, and that looks like it's going to turn out right, or negative 1. So it is negative 1. That way when the 6 n's bump up against it, that'll add up to negative 12n. You'll see. 6 times 6, 36 n squared minus 6n minus 6n plus 1. It does come out right, so the right way to write that would be 6n minus 1 squared. Okay? And that about does it for the first section of 2.3. If you worked all of those problems with me, that'll help you be ready for when I turn the page to the more complicated version.